Welcome back to Chemistry from Jay's House. It's more logarithms. Woohoo! I didn't collect homework, I didn't go over homework, but I know what you guys are thinking. Jay sure talks a lot, but what's the point? Let's go write the date. I hope it's the 29th when you're watching this. That date's probably wrong, so, update it in stiffs. Let's go left, right, the point. Do you see that? Yeah. And the point is, how are hydronium and hydroxide concentrations related? That is a poorly drawn E. Well done, me. So, how are hydronium and hydroxide concentrations related? They're not. Now, if we remember again, if you are an acid, you add a proton to water, you make hydronium, which is H3O+. So we're going to talk about that. I'm going to just kind of put that up there to remind us that hydronium is H3O+. And if you're a base, you eat protons and you change water into hydroxide, which is OH negative. So I'm just going to put that up there to remind us that those are the two things we're talking about. So if I put a substance in water, some substances, if they're acids, make that. And some substances, if they're acids, make that. And if they have really low pHs, they make tons of this out of water. Or if they have really high pHs, they make tons of this out of water. And if they have middle in pHs, anything around 7, they really don't make much of either of those. So that's what we're talking about. And I have a note that we're going to take. So skip a line, so there's space for the point in your notes. And I just call it pH math. When you first see it, it's going to look very, very daunting. By the end of this video, you should be surprised at how easy the math is. So just write this down. If the hydronium concentration is 10 to the negative, and I'm just going to use the variable A, right? I don't know what it is, but I know that A is between 0 and 14 because that's the only possibility. And the hydroxide, did I fit it in? Oh, I did. Concentration is 10 to the negative B, again, a variable from 0 to 14, then A plus B equals 14. So just write that down. And I'm going to color code it. It doesn't have to be color coded in your notes, but I'm going to color code it. And so I'm going to say I'll make A green. Aren't all acids green? No, actually they're clear. Oh, okay. And B, I'll make that blue for base. And then that means that A plus B is 14. So I just want to be clear, the only math you have to do for this unit is add up to 14. I will give you an A and you'll have to find the B that adds up to 14. Or I'll give you the B and you have to find the A that adds up to 14. How do we do that? Subtract. There it is. Subtract. I give you the A, subtract it from 14, you get the B, or vice versa. Subtract. I'm asking you to subtract from the number 14. That's it. I believe in you guys. You got this. So How does this relate to pH? Well, if we remember correctly, pH, if I take, I don't know, we'll say the pH of 5. So we'll say the pH, lowercase p, capital H, of 5. What that equals is a hydronium concentration. So this would be the green of 10 to the negative 5. Again, there's no math here. Do not math. Do not math at all. Copy. pH of any number is simply a concentration of hydronium ions of 10 to the negative 5. So if we are talking hydronium, then no math. That is actually what pH originally stood for, the power of hydronium. So what it was simply pH was a shorthand for not having to write a concentration of hydronium ions of 10 to the negative 5. We would just say pH of 5. They mean the exact same thing. Concentration of hydronium ions of 10 to the negative 5 is the exact same as saying it has a pH of 5. Notice how much faster that is. So there's no math if you're going from pH to hydronium concentration. None whatsoever. All you do is you take that number and you raise 10 to the negative of it. That's it. I'm not even going to make you calculate that. I'm not even going to make you find out that that's 1/100,000th. You don't even have to do that. You just have to tell me that if I give you a pH of 5, you have a hydronium concentration of 10 to the negative 5. Whoop. Okay, so I recommend pausing the video, copying this down, and then coming back. Welcome back. This is best taught through everyone's favorite, a chart. We love charts, just like we love graphs, and we love raising things to negative powers. I know, that's why I'm doing it. So let's make a chart, and we're going to look at 3 things. One thing we're going to look at is we're going to look at pH values. Another thing we're going to look at is hydronium concentrations. And remember, that's these guys, the hydronium concentrations. So hydronium concentrations, that means if I take something, if I take whatever this is and throw it in water, I would expect that number of waters to change into this. That's what hydronium concentration. Concentration is, I started with this, and then I threw this stuff in, and I got some concentration of that. And then we have over here hydroxide concentrations. And again, hydroxide means I've stolen a hydrogen from water. Yay, look at me. And I got away with it too, because there are no meddling kids. So this is what we are going to look at. Well, let's just start throwing numbers in. So if I was in class, I'd say, give me a number between 0 and 14. And you guys would yell things like 15 and -5 because you're teenagers. So I'm just going to start off with 11. Now again, this is the no math. So I'm going to move this up a little bit so I can write no math. There is no math that happens here. I simply write 10 to the negative 11. That's it. There's no math. A pH of 11 is shorthand for a hydronium concentration of 10 to the negative 11. That's what pH means. It's just so I don't have to continually say hydronium concentration of 10 to the negative. I just say pH. And hydroxide concentration, Well, there is some math here. Oops, helps if you grab the right marker. Subtract from 14. And here's what I mean by that. If I have a pH of 11, then I have a hydroxide concentration of 10 to the negative. It has the exact same format as hydronium concentrations. Both of these are going to be 10 to the negative something. And this is just going to be a number from 0 to 14. So we'll see whole numbers here, maybe a couple decimals, but these are just going to be regular kind of counting numbers, and these are going to be 10 to the negative something numbers. Now, I do have to do math. I don't get to just write 11. Here I get to just write 11, but here I actually have to subtract from 14. So 14 minus 11, I put that in my calculator, and I get the number 3. Now, if we look at our note that we just took, this plus that has to equal 14. Well, 11 plus 3 does equal 14 because I subtracted from 14 to get that. So, to do this chart, you do no math here. You simply take that number and raise it 10 to the negative that. And then over here, you subtract that from 14 and get this. That's all I'm asking you to do. No math, and then subtract from 14. Please, get these right. Please. So let's look at another number. Let's say 2. What do I do here? Hopefully everyone's yelling, no math. Just raise 10 to the negative, whatever that number is. And I'd say, you're right. Well done. Look at you. You actually paid attention. I'm surprised. If only paid that much attention when we were in class physically. Over here, you'd say, oh, there's a little bit of math, a smidge of math. I have to take this number and subtract it from 14. So I write 10 to the negative, because everything is 10 to the negative. And I say 14 minus 2 is 12. Oh, okay. That's kind of cool. Let's do one more. Let's do, I don't know, 8. So here is 10 to the negative. In fact, I could even write 10 to the negative, 10 to the negative, 10 to the negative. This one's going to be wrong. And over here, I could write 10 to the negative, 10 to the negative, 10 to the negative, 10 to the negative. How is that going to be wrong? You'll find out later. Stop bothering me. I'm teaching. Okay, so I can just kind of pre-fill these, except for this one. And I go, okay, 10 to the negative 8, because I do no math. And here I have to subtract 8 from 14. I get out my calculator and I find out the answer is 6. And 8 plus 6 is 14, so I know I'm right. Hey, this is starting to feel kind of good. I kind of like this. Okay, what about, I don't know, 7? Now we know something about 7. We know that 7 is neutral. And what that means is that's where acids and bases are equal. It's neither. So there should be something unique about 7. I should see something mathematically about 7 that makes me feel that it's neutral. Somehow these concentrations would be neutralized. Well, let's find out. Again, 10 to the negative whatever it is. So this time I do 7 because this column is no math. And here I do 14 minus 7, and pulling out my calculator, I find out that it's 7, and I go, woo! Hey, 10 to the negative 7, 10 to the negative, hey, these are the same. Huh. And that means this tells me how acidic something is. This tells me how basic something is. So, in case I didn't make that clear, this is the acid column. This is the base column, right? Because acids make water change into hydronium, bases make water change. And the strength of this equals the strength of that. These are the same number. It's neutral. Neutral. That's why 7 is neutral, because the strengths are the same. They neutralize each other. Gotcha. Okay. Let's just bang out, I don't know, one more. We'll do 5. Just really drill this down and make it super boring. Hopefully you're like, oh, can you just fast forward and say 10 to the negative 5? Yeah, I get it. I don't do any math. And then I do 14 minus 5. 14 minus 5, I pull up my calculator and I get 9. And hey, that's correct. Sweet. Okay, now I'd like to look at what about the very ends? So I understand kind of the middle values and I understand the neutral value. What about one of the ends? Let's put the smallest possible value. That is the strongest acid we know. It's called a perfect acid. If you want to get real nerdy about it, I can even write that in. And that means that 100% of the acids go, take that. Now they're no longer acids and off they go. So 100% of the acids are going to react. That means, oh wait, I wonder what constant, anyways. Okay, so it's 10 to the negative 0 because I do know, whoa, hey, you said this was going to be wrong. And it is wrong because there's no such thing as negative 0. The only time it's not 10 to the negative something is when there's a 0 value. If there's a 0 value, there's no such thing as negative 0. 0 in kind of a real world sense is nothing. Negative means you kind of owe the world. So how do you owe the world nothing? Well, if you don't owe the world anything, then you don't owe anything, and it's not negative, it's 0. So if you write a negative there, I will take credit back. I will mark you off partially because, yeah, you figured out the 0 goes here, but you didn't quite follow all the rules because you put a negative. There's no such thing as negative 0. So this is the one time it's not 10 to the negative something. Now, let me see if I can do this math. 14 minus 0 is... I can't power up the calculator. 14. Okay. There we go. Okay. Oh, wait. 10 to the 0. Wait, isn't anything to the 0 1?